Alright, so to start off our matter unit, we actually want to start by looking at the three phases or states of matter, or main phases or states of matter, and also the fourth phase or state of matter that also exists. So to start off, we're going to look at the solids. Solids have particles in them that are tightly packed, and they have a regular, orderly arrangement, kind of like in this picture. If you look in your notes, you actually have a small area underneath there where you can actually draw. And so if you wanted to do that, then you could draw something that kind of looks like this, where you have the nice, neat, well, started off neat, orderly arrangement of them. They're in nice rows, and all of the particles actually touch each other. Now, the particles actually are not capable of moving from place to place, but they do vibrate in place because of the heat that they contain. So while they aren't actually what we see as moving, we can't see them moving, they actually are. Solids have both a definite shape and a definite volume. So in other words, it's defined. We can actually measure all of these things. And they are not easily deformed. Now this is not deforming, like for instance hammering on a piece of metal, to change its shape. It means in here these particles and pieces, in other words how they're arranged with each other, that doesn't change as easily, very easily at all, in a solid. Liquids are the second phase of matter, and they have no definite shape, but a definite volume. So if I take a liquid and I pour it from one container to a different shaped container, it doesn't keep the shape that it once was. Whereas solids, if I move it from one place to another, it's going to keep the shape that it has. But we can measure the volume of liquids. They can be measured in a tool like a graduated cylinder. The particles roll and slide past each other. They can more easily move around, because if I look at that particle arrangement, they are still touching. Okay, so it would look something like this, where I have the particles touching, but as you can see, we've got some more space in between them. So this one can slide through here, that one can go through there, that one here, that can slide up in there, that one can roll. And that's the idea, is that they have this room that they're able to move. The particles have more energy in the liquid state than the solid state. And kind of what I alluded to before with the shape issue, they take the shape of the container that they are in. Now, liquids have the ability to get poured, and how easily they pour or flow is referred to as viscosity. The last characteristic of liquids is they expand as the temperature increases. So if you think about a pot that's been full of water and that you heat up on the stove, one of the reasons why it boils over is because that liquid is actually expanding. Yes, there is some increase and bubbling with the boiling, but one of the reasons why it kind of looks like it rises is that water actually will expand. This is actually how a thermometer works. As the temperature goes up, the liquid that's in the tip of the thermometer expands, and it goes up along the scale. Gases are our next one. Gases have neither a definite volume nor a definite shape. These particles have enough energy to move freely. So if I were to draw a particle diagram for them, it would look something like this. Okay? They are not actually touching, but they are moving. And they're actually moving quite fast. Okay, so they are separated by large distances and don't touch each other. They have more energy than in the liquid state, and they will fill the container that they are in. So in other words, let's say I'm in a room and I spray, let's say Febreze in one corner. Eventually the people in the other corner will actually be able to smell that. Gases also expand as the temperature increases. So that's the principle behind how a hot air balloon works. You put in regular air, you actually heat that up. That gas actually expands, some of it escapes, and the air inside of the balloon is actually less dense than the surrounding air. I'm always surprised at how many students think that hot air balloons have helium in them, and they don't. And this is just a funny cartoon about gases. Gases also exert a force called pressure. This is the force of the collisions of the gas particles with anything in their path. A lot of times this is going to be the walls of the container, so it's how many times or how hard they crash into the sides. The more times that they crash or collide, the higher the pressure. Because I can actually take, for instance, gas particles and compress them. I can push them closer together. If I push them closer together by compression, then I'm actually going to have a higher pressure because they're going to be more likely to crash into the sides of the walls of the container. Now, we're not actually going to calculate any of this, but I just kind of bring it up because gases do have this property that makes them kind of unique. The unit for pressure is referred to as the Pascal in SI. Now, the last phase of matter that you're probably not as familiar with is plasma. And plasmas are basically superheated gases. They are very hot gases, and the particles within the gas have an electrical charge. What happens is, as you heat up these gas molecules to a very high temperature, they begin to shake. And when they shake violently, they split apart into the nucleus and the electrons. And the electrons at this temperature are going super fast. And when they go this fast, they produce a magnetic field, which we can use for electricity. Examples of things that are plasma are the sun and the stars. It is rare on Earth, but we do have it in the form of lightning. Now, I've got a summary here of the three main phases of matter in terms of their characteristics of mass, volume, shape, and compressibility. This is actually a really good reference tool for you to study for your test. Now, the other thing I want to go through is this graphic organizer that you've been given. Okay? So, we've got our different states of matter, and if you look at this one, the solids, and solids have particles that are tightly packed. And that results in a definite volume and shape. The state of matter that has particles that can slide past each other are liquids. And they have a definite volume, but no definite shape. Now, the one that has no definite shape or volume are our gases, and these particles are able to freely move. Okay? So that's kind of a brief review of most of the things that you probably already knew about solids, liquids, and gases. In our next segment, what we're going to do is actually take a look at some of the properties of matter more in general.